Good morning, Rasa community. Welcome to me adjusting my levels. Welcome to the reading group, where we read a paper together. That's what we do. And this paper is super relevant to all of us who are working on chatbots or conversational AI, or, if you're not working on those things, still relevant to you. It is, hi Native Learner, hi Amina, welcome. What will it take to fix benchmarking in natural language understanding? And this, so the link is to arXiv, but the paper has been accepted for NAACL, which is the North American Association for Computational Linguistics Conference. And it's one of the big publishing venues in NLP, so it's undergone peer review. And this is actually a preprint and not just a only print, I guess. Anyway. And the paper's by Samuel Bowman and George E. Dahl. If you're not familiar with Sam Bowman, he knows quite a bit about benchmarking in NLU. His research group did the glue benchmark, which you might have heard about, in superglue. And he does a lot of stuff around evaluation in NLU. And I'm less familiar with George Dahl's work. Hi, Vasavaraj. Sorry if I'm saying that incorrectly, but welcome to the stream. All right, let's get started. Ooh. So I've got my L3AI mug, and the next L3AI is coming up. It'll be a free online conference. We're going to talk about conversational AI, trends, like recommendations. There may be some tutorials. Should be a good time, so check it out. Hello, Enrique. Welcome. What will it take to fix benchmarking in natural language understanding? Sam Bowman and George E. Dahl. Abstract. Evaluation for many natural language understanding NLU tasks is broken. Unreliable and biased systems score so highly on standard benchmarks that there is little room for researchers who develop better systems to demonstrate their improvements. The recent trend to abandon IID independently distributed. Individually and independently distributed? Y'all, I've forgotten what the first I stands for. Imperial Irrigation District. Nope, that's not what I'm looking for. Statistics, just gonna add that to the end there. Independent and identically distributed. There we go. The second I is for independent. Identically. Benchmarks in favor of adversarially constructed out-of-distribution test sets ensures that current models will perform poorly, but ultimately only obscures the abilities that we want our benchmarks to measure. In this position paper, we lay out 4 criteria that we argue NLU benchmarks should meet. We argue that most current benchmarks fail at these criteria, and that adversarial data collection does not meaningfully address the causes of these failures. Instead, restoring a healthy evaluation ecosystem will require significant progress in the design of benchmark datasets, the reliability with which they are annotated, their size, and the ways they handle social bias. Rashab says identically, thank you. There is a bit of a delay between where I am and y'all who are watching, but I do appreciate it. So basically what they're saying is, right now, benchmarking is flawed because systems that are extremely biased in one way or another, and this is biased in the statistical sense, can do really well. There's been a trend towards not having ID benchmarks. So basically benchmarks where the test and the training data set are drawn from the same distribution, but they're not, there's no overlapping data. And instead moving towards adversarially constructed benchmarks. So like there are intentionally things that are gonna trip a system up that's overfit to the original training data in the test data set or the evaluation test data set. But that is not a solution is what they're arguing here. And they're gonna say, hey, benchmarks should have these specific qualities, and most current benchmarks don't. And I'm sure they will talk about what those qualities are. All right, introduction. A large and impactful thread of research on natural language understanding, NLU, and I should say NLU is something that's very important for for conversational AI in particular, but in general, it's the task of taking raw text data and creating from it a computer readable representation of the information, basically. A lot of times people will refer to text data as unstructured data, and that drives me up the wall because all language has structure. But when people talk about taking unstructured data and turning it into structured data, that would also be unstructured text data. That would also be sort of a way of talking about NLE. Has focused on improving results on benchmark data sets that feature roughly independent and identically distributed, there we go, training, validation, and testing sections drawn from data that were collected or annotated by crowdsourcing, and a bunch of examples. And that second example is the same first author as this paper. 2015, that's probably not Glue, that's probably a different one. Recent methodological progress combined with longstanding issues in crowdsourced data quality has made it so state-of-the-art systems are nearing the maximum achievable values on most of these benchmarks and are thus unlikely to be able to measure further improvements. So in the experimental design literature, we would talk about this as people being at ceiling for the task, so they can't get better, and if the task is so easy that everyone's at ceiling, it can't help you evaluate differences. And again, in the behavioral experimentation literature, that is differences between people and their performance in specific behavioral situations. And in the system evaluation literature, that is evaluating systems and seeing how they do things differently. At the same time, these apparently high-performing systems have serious known issues and have not achieved human-level competence on their tasks. Barrio et al. 2020. What paper is this? Beyond accuracy. Oh, yeah. And a checklist. Did we read checklist in the reading group? We may have read checklist in the reading group. I know I have read that paper. Did I do it on the internet in front of people? I think so. I think we read this paper. So go and check the reading group playlist on our YouTube, and I think it'll be in there. I'm pretty sure. So various ways in which systems are doing things that, language is a system produced by and for humans, and these computational systems are not being human-like in the way they interact with this linguistic system. I should stop saying system. Progress suffers in the absence of a trustworthy metric for benchmark-driven work. Newcomers and non-specialists are discouraged from trying to contribute, and specialists are given significant freedom to cherry-pick ad hoc evaluation settings that mask a lack of progress. Citation there for that as well. Yeah. My thinking here is, and they may bring it up here, is it's a little bit like the evolution of Kaggle over time. If you're not familiar with Kaggle, it's a website that does machine learning competitions, and also I used to work there. They host data sets, and there's a in-browser coding environment they support as well. And back in the early days of Kaggle, it was a competition, and you build a model, and then it's evaluated on a hidden evaluation set, and then the model that does best on the hidden evaluation set wins some prize, whatever it is. And in the early days of Kaggle, it was I don't want to say it was necessarily less competitive, but there were fewer people doing it, and you didn't immediately see like 3 teams of people who have done a bajillion Kaggle competitions ranking super high. So it was much easier and for a beginner to get started and see relatively good results, and get, become a part of the community and start to contribute meaningful results and, learn more and become, proficient at this task. Whereas now, because there are many more people who are interested in doing it, and there's a lot more specialized knowledge, it is much harder for a beginner to do well. And in this case, they're arguing that that is happening in NLP, but it's not because, you know, necessarily that a lot of people are doing NLP, but rather it's because the way that the benchmarks are constructed and are being evaluated is causing these problems. Anyway, sorry, a big aside about Kaggle, but I think it's one of the big criticisms that people usually have of Kaggle is that it focuses too much on benchmarks. And as a result of, you know, trying to maximize a specific thing, people usually build extremely complex, large, very expensive to train systems that maybe are not as helpful in other ways. Anyway, a little bit of a tangent. Let's get back to the paper. The plight of benchmark-driven NLU research has prompted widespread concern about the assumptions underlying standard benchmarks and widespread interest in alternative models of evaluation. As is an especially clear example, the documentation for the recent Dynabench benchmark suite argues that benchmarks saturate, benchmarks have artifacts, researchers overfit on benchmarks, and benchmarks can be deceiving, and use these claims to motivate abandoning the IID paradigm in favor of benchmark data that is collected adversarially by asking a broad population of annotators to try and fool some reference neural network model. So other people have also noticed these problems with benchmarks and are proposing other ways of constructing benchmarks. I did not mean to click on that link. Back up we go. The Dynabench approach falls into the broader category of adversarial filtering. Adversarial filtering starts with a pipeline that produces candidate examples for the task, often through crowdsourcing, and then constructs a data set by selecting those examples from the pipeline where one or more machine learning models fails to predict the correct label. So a bunch of examples, they are used to, a bunch of labeled examples are created. Systems are asked to evaluate them. Only the ones that systems fail on are included. This approach is appealing in that it guarantees that, at least in the short term, existing approaches to data start construction can be patched to keep producing data that will challenge current systems. I mean, the big problem with that, right, is that, especially if the adversarial examples are from like a certain population, and particularly in the case where researchers can see those adversarial examples, it can be easy to start fitting onto the evaluation data set. I don't exactly know how Dynabench is set up. Maybe the evaluation data set is hidden, but that is the challenge there, I would say. However, collecting examples on which current models fail is neither necessary nor sufficient to create a useful benchmark. Interesting. So this is a point that these authors are making that is in direct contradiction to other people who are working on benchmarks. Among other points of concern, this approach can create a counterproductive incentive for researchers to develop models that are different without being better, since a model can top the leaderboard either by producing fewer errors than the adversary or by simply producing different errors, because examples on which these new errors will be tested will not appear in the evaluation set. One could attempt to do this by, for example, pre-training new models that deliberately avoid any data that was used to pre-train the original adversary model in order to minimize the degree to which the idiosyncratic mistakes of the new model line up with those of the old one. The incentive can slow progress and contribute to spurious claims of discovery. So what they're saying here is this using models as a filter here is a little bit like evolution, right? Like there's a niche, right? And you can see that there is like something in this niche, but it's not exploiting some resources in its environment. So you are, you know, being asked to create a model that is going to exploit those resources, but is maybe not as good as exploiting resources as the other model is. Except it's a very artificial situation because the resources that are available in this sort of like toy environment are not necessarily a good match to the resources of the world as a whole. So being able to do well in the toy environment is going to happen because of a mismatch between the models, right? Rather than them having good ecological validity. So to give a more concrete example, if I have a robot that picks up blocks, right? And the blocks that doesn't pick up, I are like, okay, these are the super hard blocks, and the robot that picks up blocks uses like a little clippy clap. Then I might be like, okay, the ones that it misses are the ones that are spherical, so I'm going to build a robot that has a plunger that's really good at picking up spheres, because those are the errors that I'm going to be evaluated on. Even though, perhaps, in the wider environment where you might deploy such a robot, using a little clippity claw would be more beneficial than using a plunger. Because you're being evaluated on how well you do in the situations where the other robot does badly, you might end up having a robot that's like, I think this robot is good because it is different to the original robot, rather than because it solves a wider variety of tasks well. I know that that was a very, very weird little example I just came up with, but particularly with this type of like position paper, I find it very helpful to like come up with more concrete examples. Anyway, and if you keep doing this iteratively, you're going to end up with a bajillion robots with increasingly specialized picker-upper mechanisms that may or may not actually work well for picking up things in the world that you need them to pick up. This position paper argues that concerns about standard benchmarks that motivate methods like adversarial filtering are justified, but that they can and should be addressed directly, and that it is possible and reasonable to do so in the context of static IID evaluation. We propose 4 criteria that adequate benchmarks should satisfy. Coffee. That's not a criteria, that's just, I wanted to drink some coffee. Benchmarks should offer a valid test of the full set of relevant language phenomena. I agree with this, but I think it's not going to be a popular position. They should be built around consistently labeled data. And they should offer adequate statistical power. Sorry, there was no and there. And they should disincentivize the use of systems with potentially harmful bias. I think these are all fantastic points. I am on board with them. So far, we'll see. We'll see what the authors say from here. We then briefly survey some ongoing or promising research directions that could enable us to meet these challenges, including hybrid data collection protocols involving both crowd workers and domain experts, larger scale data validation, and auxiliary bias metric datasets attached to benchmark. I think these are all fantastic. I think these are all things that would absolutely improve NLU evaluation. They all sound expensive. They all sound like it's going to be a little bit hard to get people on board. So yeah, let's see where we go with this in the paper. Oh, is T5 state of the art right now? Good to know. All right, background. The problem. Performance on popular benchmarks is extremely high, but experts can easily find issues with high-scoring models. The GLUE benchmark, a compilation of NLU evaluation tasks, has seen performance on its leaderboard approach or exceed human performance at all 9 of its tasks. And this is, I think this is a headline that we have seen a lot, that like, oh, X system is at human performance. I remember there was like Microsoft had like a big splash about one of their ASR systems about that a while ago. The follow-up SuperGLUE benchmark project solicited dataset submissions from the NLP research community in 2019, but wound up needing to exclude the large majority of the submitted tasks from the leaderboard because the BERT model was already showing performance at or above that of a majority vote of human crowd workers. Of the 8 tasks for which BERT did poorly enough to leave clear headroom for further progress, all are now effectively saturated. State-of-the-art performance on the highly popular Squad 2, it's a question-answering dataset, English reading comprehension leaderboard has long exceeded that of human annotators. And I think if you read just this paragraph in isolation, you'd be like, well, okay, what's the problem? NLP is solved. We are good to go. We understand natural language. Great, what do we need? To do from here, we're done with this research area, and not the case. Very much not the case. Ample evidence has emerged that these systems that have topped the leaderboards can fail dramatically on simple test cases that are meant to test the very skills the leaderboards focus on. This result, this is the checklist paper, and is this the paper that talks about? No, this is a different paper. I don't think I've read this one. Oh, it's by Dahl. Anyway, sorry. Yeah, this is definitely something I should put on my my to read list. But a good example of that, and I'm sure they'll talk about specific examples, is a negation task where what the model learned was to say that it was negated if there was no in the sentence, like the word no, but not to actually have a clear understanding of, you know, the scope of the negation. What happens if it's like in a name and it's not actually, you know, the particle. Anyway, just an example there. The results have made it clear that our systems have significant room to improve. However, we have no guarantee that our benchmarks will detect those needed improvements when they're made. Most were collected by crowdsourcing with relative limited quality control, such that we have no reason to expect that perfect performance on their metrics is achievable, or that the benchmark will meaningfully distinguish between systems with superhuman metric performance. While the true upper bound on the performance for any task, Bayes error, is not measurable, the fact that our systems have exceeded serious estimates of human performance leaves us with no reason to expect that there may be much more headroom. So, you know, if we're sort of estimating average human performance here and our systems are here, and like how much more difference is there between the theoretical maximum of getting everything correct and like what's actually doable from a machine learning standpoint? We can't say. In addition, many of our best models display socially relevant biases that render them inappropriate for deployment in many applications. The state-of-the-art T5 model, for example, shows far more sensitivity to irrelevant gender information than humans do when making co-reference judgments, according to results on the Superglue leaderboard with the DNC Wino gender dataset. Yeah, so this is a specific problem. So this example is sort of part of a broader problem where if there is an existing bias in your underlying training data, for example, nurse and woman being used together more than doctor and woman, most of our neural methods right now will not just capture that, but actually amplify it, right? Because what neural networks are really good at in sort of this languagey space is picking up relationships between tokens. It's like a fancy bag of words, basically. And if there is an existing relationship that is, you know, more in one direction than the other, it will be like, okay, yes, I'm focusing on this, and it'll sort of continue on that trend and extrapolate in that way. And that can be a useful property, but particularly when it comes to things like social bias, that can be a very bad property that will make you very upset as a practitioner if your system has it. There is a lag between the audio and the video. Yeah, I don't know what's causing that. Yeah, I'll look into it. Add it to my to-do list. Check out video lag is on. All right. Thank you for letting me know. Okay. Our best current benchmarks do little or nothing to discourage harmful biases, and by building largely on crowdsourced or naturally occurring text data, they likely incentivize the development of models that reproduce problematic biases, at least to some degree. Yeah. Yeah, and so if I could sort of summarize the trend of data set and benchmark creation, so certainly while I've been in the field, it went from carefully constructed annotated data sets by, well, okay, slightly before my time in the field, because we were definitely seeing a lot of crowdsourced larger data sets when I was like the mid-2010s. We went from, you know, very carefully linguist annotated, carefully collected, very high quality data sets that were smaller, so larger data sets with less quality control that, you know, were bigger. I know I said larger already, but that was really, there was a trade-off moving towards scale and away from more rigorous quality control. And this happened not just in NLP, it also happened in computer vision. And I don't really know much about data set collection outside of those particular fields, specifically for machine learning purposes. But as a result, most of the well-known big data sets have quite a few errors in them. I think, don't quote me on this, but I think I remember seeing something recently about ImageNet having like a 10% error rate. That seems very high, and I don't remember the exact source, and I was just like, oh, that's interesting. I don't use ImageNet and did not file it away anywhere, but that sort of thing. Har says, it's not recorded. It is recorded. Yeah. Oh, sorry, it's being recorded, but this is live. Hi. I get what you're saying. Hi, Habib. Good to see you again. Anyway, so broader questions of, you know, what data is important, how do we collect it, how do we annotate it, and what does data need to be like to be in an evaluation benchmark? The goal. This paper lays out 4 criteria that we would like our benchmarks to satisfy in order to facilitate further progress towards a primarily scientific goal. Building machines that can demonstrate a comprehensive and reliable understanding of everyday natural language text in the context of some very specific well-posed task, language variety, and topic domain. Yeah. I would say this is a scientific goal. I would say that building systems is an engineering goal, but building systems that have ecological validity just means like they work in the larger system, and including interactions with other things. And yeah, like that's what I want from a system, right? If I'm building a virtual assistant, I want it to be able to handle, you know, the specific task, right? So maybe that is intent classification, maybe that is entity extraction, given the language variety that my speakers are using. So for me, maybe American English, maybe global English, and topic domain. So, you know, the specific, you know, if you're a company like booking a flight and talking about airplanes and whatnot, for example. Yeah, is this a research paper? Yes, this is a research paper. So this is, I would say it's more of a position paper, which means that the contribution of this paper is suggestions about ways to think about things going forward as a field. And it is by Sam Bowman and George E. Dahl. Sam Bowman's from New York University and George E. Dahl is from Google Research. Among language understanding tasks, we focus on those that use labeled data and that are designed to test relatively general language understanding skills, for which of the design of the benchmarks can be especially difficult. Okay, so specifically labeled data. So this would be something like intent classification, where you have a bunch of intents that you've gone through and been like a bunch of utterances that you've gone through and you'd label the intent. And relatively general language skills, language understanding skills. So these are, yeah, I'm assuming the authors will talk more about this. We distinguish between a task and a benchmark. A task in our terms is a language-related skill or competency that we want to model to demonstrate in the context of a specific input-output format. NLU is natural language understanding. Yes. Okay, so a language-related skill or competency that we want to model to demonstrate in the context of a specific input-output format. This is going to be some sort of data input, some sort of data output that's going to be consistent across the task. And it is a specific language-related skill or competency. So this sounds like the authors here are arguing that the goal is really to model a human language behavior. So a human language skill, so something like understanding negation or competency. So something like understanding, I don't know, yeah, I don't know how they're differentiating between skill and competency here. And then a benchmark attempts to evaluate performance on a task by grounding it in a text domain and instantiating it with a concrete data set and evaluation metric. Okay, so a task is would be like question answering. and then a benchmark would be like squad, so a specific data set for question answering. Okay, I'm picking up what they're putting down here. Oh, I deleted. Oh, so I am, there's quite a bit of lag between the chat and me. So one sec, just, ban a spammer. Okay, good to go. As a rough example, multiple choice reading comprehension question answering is a task. Sorry, as a rough example, multiple choice reading comprehension question answering is a task. So this is the task where you read a passage of text, you have a multiple choice answer, and you pick the correct answer. So very standardized text sort of stuff. Where the Cosmos benchmark attempts to test using an accuracy metric over a specific sample of passages and questions from the English personal narrative domain. So people are talking about life stories in English, and then there is a sample passage and questions, and then that is the benchmark. There is no general way to prove that a concrete benchmark faithfully measures performance on an abstract task. Nevertheless, since we can only evaluate models on concrete benchmarks, we have no choice but to strengthen the correspondence between the two as best we can. So this is a good point. Yeah, so let's say I have a question answering data set, and I have a benchmark of questions that I can answer. Doing well on the benchmark does not necessarily mean that my system or my approach is going to work well on every, like, all of the tasks, all of the different specific. Okay, let me back up. You have an approach and you want to measure it. You have an approach for a task, and you think that it is a general approach that will work for this specific task in a variety of situations. And the way that you measure it is you measure it using a benchmark that is a specific data set. It's a specific instance of the task. So you are sampling one potential way. I guess it's not potential, it's a real way. So you're analyzing your system on a single sample out of the population of instances where that task can be used, if that makes sense. And doing well on that benchmark doesn't necessarily mean that your system is going to do well on, honestly, any other of the potential tasks in that domain. You may have developed an approach that works really well for this benchmark that doesn't extrapolate to other instances of the task. It's basically what they're saying here. Nevertheless, since we can only evaluate models on concrete benchmarks, we have no choice but to strengthen the correspondence between the two as best we can. There's no way to sort of like reach into like the cloud of the task and pull down a bunch of benchmarks really quickly and easily and sample all of them and sort of see how well you do given all of the possible things that your system might need to do. Yeah, I think this is an interesting way of thinking about benchmarks. We set aside the evaluation of computational efficiency and data efficiency. No! If you watch a lot of the reading groups, you know that this is the thing that is very important to me. Because I am a practitioner and I work with practitioners, and we don't have unlimited data and compute. Stuff's expensive. Despite its relevance to many specific applications of language technology, we will not fully set aside issues of social bias. Even though it is possible for the same system to demonstrate both adept language understanding and harmful social prejudices, ethical concerns prompt us to argue the community-wide benchmark should identify and disincentivize potentially harmful biases in models. Yeah, I think that's a really good point. Because benchmarks in the NLP community are specifically creating a community norm and a shared task that people are working towards, they're saying that it is important to make sure that the benchmark itself is not incentivizing learning and replicating and amplifying these biases. And I actually think that that is I think it is more reasonable to address that than it is to address data efficiency. I'm just going to set aside, but computational efficiency, because computational efficiency is going to be something that varies across models, whereas, you know, biases within the data set, particularly from applications that are approaches that learn very directly from the data set, is going to be, is not necessarily, I don't know if y'all picking up what I'm putting down. I'm having a hard time putting this into words. Computational efficiency is a quality of models, not measuring bias is, or including data that results in models that must be able to handle and replicate bias is a data set problem. I hope that makes sense. Hi, Dan. Am I streaming somewhere else too? Yep, so I stream to both Twitch and YouTube, and I try to keep up with both chats. The widespread, oh, sorry, so there's a citation, footnote here. The performance of models like Roberta or T5 on benchmarks like superglue that include some coverage of social bias is a good example of this, and typical human behavior is an even better example. The widespread sharing of trained models among NLU researchers and engineers and the fast pace of NLP R&D, research and development work, mean that it is easy for systems designed with scientific goals in mind to be deployed in settings where their biases can cause real harms. Yeah, a great example would be conversational AIs. With recent initiatives around data documentation, like data cards, we should reduce the accidental deployment of models based on inappropriate data. And I think this is the, one of these is the data cards paper. Data statements, and it was data sheets for data sets. Yeah. I didn't realize how it was on that page. I wish I could go back up to where I was easily. We will also set aside few-shot learning, in which tasks are made artificially difficult by training models only on small subsets of the available training data, as was prominently used for GPT-3 by Brown et al. 2020. This paper focuses instead on the case where one is interested in reaching excellent performance on some language task and is willing to collect data or otherwise expend resources to make that possible. And I would say that is a huge part of the development cycle, certainly for a Rasa assistant, is the data collection and annotation. While few-shot learning represents a potentially impactful direction for engineering research, and success on some task in few-shot learning setting is clear evidence of success more generally, artificial constraints on the use of training data do not fit the broad goals laid out above and do not fit many applied settings. Have some water. Sorry, I know my chair is squeaky. Right. So in this section, they're really setting out the limits of what they're going to be working on, and they're being, you know, clear about the specific thing that they're talking about. And this is something that I think people often bring up as like a problem with academic work, is that it's so narrow, but it's supposed to be narrow. You're supposed to be very concrete about what your contributions are, and, you know, how they relate to other related work. And, you know, so here's like all of the related work. These are the things that are relevant to me. Here's the specific thing that I'm focusing on. It's good scholarship. 4 challenges. The paper focuses on 4 criteria outlined in Figure 1 that we argue effective future benchmarks for NLU tasks should satisfy. We believe that no current benchmark for any difficult broad domain NLU task satisfies all 4. Let's do a little scroll up. All right, so section 1. Good performance on the benchmark should imply robust in-domain performance on the task. We need more work on dataset design and data collection methods. Benchmark examples should be accurate and unambiguously annotated. Test examples should be validated thoroughly enough to remove erroneous examples and to properly handle ambiguous ones. Yeah, and so the problem with ambiguity is for specifically the supervised learning labeled data situation, if an item can have more than one label, that's a problem for a system whose job is to pick one and only one label for every item. It's just not solvable, right? And including a lot of ambiguous examples is going to make your machine learning problem kind of untractable, honestly. So this will come up a lot with Rasa assistants when people have they're using intent classification and they have an utterance that can be part of multiple intents. And usually that means either A, you should redo your intents, or B, that example should be included in end-to-end learning and not go through the intent classification process at all. Benchmark should offer adequate statistical power. Benchmark data sets need to be much harder and or much larger. So they should be, there should be enough instances that are hard in the data set that it helps you pull apart the differences between systems. And again, this is really sort of an experimental design consideration, I would say. Benchmark should reveal plausibly harmful social biases in systems and should not incentivize the creation of biased systems. We need to better encourage the development and use auxiliary bias evaluation metrics. And I'll sort of talk about this quite a bit in the future. What matters in terms of biases for your particular system is going to depend on your application, your data set, and where you're going to be deploying it. And also, like, from a legal standpoint, the locales in which you're going to be deploying it. I'm not a lawyer. Talk to a lawyer. But having a mechanism to do that, particularly for data sets that are designed to be ones that set social norms, is important. Especially given draft EU legislation. For tasks. All right, this is probably going to be a 2-week paper, but I'm okay with that. There's a lot to unpack here. Validity. If one system significantly outperforms another on some benchmark, then that result should be a strong evidence that the higher scoring system is actually better at the task tested by the benchmark. And I realize that this seems like a trivial thing to say, but it's not necessarily the case, right? Like, remember the negation bot, the bot that detects negation by looking for the presence of the word no. In other words, benchmarks are only useful for language understanding research if they evaluate language understanding. General purpose benchmarks that are designed to cover tasks like paragraph reading comprehension over Wikipedia are only effective if they test the full range of skills that are required to understand and reason about paragraphs from Wikipedia. This criterion is difficult to fully formalize, and we know of no simple test that would allow one to determine if a benchmark presents a valid measure of model ability. So how do you know, and again, this is an experimental design question. You're setting up a benchmark, you're setting up an experiment. How do you know that the experiment that you've created and the behaviors that you see in the experiment that you've created actually generalize to a larger setting and are capturing the underlying phenomena that you want to model? This criterion is difficult to fully formalize, and we know of no simple test that would allow one to determine if a benchmark presents a valid measure of model ability. Minimally, though, it requires the following. An evaluation data set should reflect the full range of linguistic variation, including words and higher-level constructions that is used in the relevant domain, context, and language variety. So basically, the data shouldn't be too similar to itself, and you should see not only lots of different words and all of the different words that are relevant, but you should also see lots of different grammatical constructions. So an example from that I keep bringing up a lot is like, you should have an assistant that doesn't just look for the presence of the word no, but also, would be able to pick up on, I'm trying to think of grammatical construction for negation. God, I'm not a syntactician. Grammatical constructions that also mean negation. Or again, speaking about like a language domain and context, somebody may, you know, negate something, but in a very polite way that if you are not familiar with the context, you might misinterpret, for example. Yeah, I'm having a hard time coming up with a specific example here. Oh, here's a better one. So for example, for intent classification, if you are trying to like build an intent classifier for people in the United States, and you are, let's say, trying to figure out what, you know, you have a system that connects freelancers and hourly workers for specific tasks for, you know, end users, and someone says, I need someone to wash my car, and they're like, oh great, here's all, you know, the local freelancers that'll come wash your car. You should also be able to understand that if someone says my car needs washed, they need somebody to come wash their car. Even though that construction is not going to be used everywhere in the United States, you're still going to find it in some places. That was a very long aside where I failed to come up with some examples. An evaluation data set should have a plausible means by which it tests all of the language-related behaviors that we expect the model to show in the context of the task. Okay, so this is modeling all of the relevant behaviors. And these are behaviors of the model, not behaviors of the humans who are producing the language. I guess this top one would be the behaviors of the humans who are producing the language. An evaluation data set should be sufficiently free of annotation artifacts that a system cannot reach near human levels of performance by any means other than demonstrating the required language-related behaviors. So basically don't include like little statistical breadcrumbs that a system could pick up on and be like, I've solved the task by noticing. A good example of this from Kaggle, was it from Kaggle? Anyway, there was a computer vision competition, I don't remember where it was, I'd have to look it up, where there were two, like it was classifying, I think it was classifying flowers or something, but the images for some of the classes of flowers had been taken by specific cameras. So you could do very well in the task, not looking at the flower images at all, but instead picking up on which camera took which photo and using that to figure out which class it should belong into, right? And that's an annotation artifact, that's, you know, a spurious statistical clue in the data that's a result of the way that it was collected, and not an actual, you know, good measure for figuring out whether or not you have, you know, like a ranunculus or a rose. If a benchmark fully meets this challenge, we should expect any clear improvement on the benchmark to translate to similar improvements on any other valid and reasonable evaluation data for the same task and language domain. Basically saying, hey, if a benchmark is doing a really good job actually evaluating how well these models handle this particular task, this particular instance of this particular task, then also we should see similar behavior on other instances of the same task and other types of language domains. The rest of the section surveys common paradigms for constructing a benchmark dataset and points to reasons why none offer a straightforward way to satisfy this criterion. Naturally occurring examples. Sorry, I was scrolling. It is intuitively appealing to, where possible, build benchmark data sets based on naturally occurring data distributions. This minimizes our effort in creating benchmarks and minimizes the risk that the benchmark is somehow skewed in a way that omits important phenomena. However, this is often not viable. So this is just sort of finding language data out there that has been produced not specifically for this benchmark. Hello, Assam, welcome. For tasks like reading comprehension or natural language inference that require multiple related texts, such as a passage and a question as input, there is often no natural distribution that effectively isolates the relevant task behaviors. Which I guess is kind of another way of saying this is an artificial task. In and of itself, this is not a thing that like humans tend to do spontaneously for fun. You don't have to do something for fun for it to be a good spontaneous behavior. But it is very hard to collect this data sort of in the wild, if you will. One can find naturally occurring distributions over questions, like those used to construct natural questions, but these will generally be tied to the specific context, to the use context of a specific NLP product, and will thus be limited by users' perceptions of the current abilities of the product. Okay. Okay, so they're saying when we do see something relevant, right, it is affected because people, the data you see is affected because people know that they're talking to, you know, an assistant. They know they're talking to a computer, and so they are talking to it in the way that they have developed expectations for computers to work. But the way that computers work, or the way that NLP systems work, changes, and changes pretty significantly. Yeah, 2019 was a while ago, specifically in the NLP world. Okay. So the fact that people are not going to say everything that they could say in the situation because they think they're talking to a computer and that's affecting their behavior means that you don't have a good representation of all the things that people would say if they believed that the computer had human-like confidence. Even for single input tasks like co-reference resolution, whoa, water. Reading group is the worst on my voice because I'm, oh, excuse me. Okay, I think that's better. The reading group is the worst on my voice. Would it help if I didn't drink coffee? I mean, it would help my voice, but it wouldn't help anything else. Even for single input tasks like co-reference resolution or close, for which any text corpus can be the basis for a benchmark, naturalistic distributions do nothing to separate skills of interest from factual world knowledge. So close is fill in the blank. So like if I had this paragraph and I just sort of like blanked out the word naturalistic and I wanted you to fill that in. And co-reference resolution is like, okay, given, you know, a specific entity in a text, a specific entity in a text, where else is this entity referred to? Or, you know, so here, right? Where does them refer to? Do nothing to separate skills of interest from factual world knowledge and can be overwhelmingly dominated by the latter, making them poor metrics for incremental progress on NLU. Credible existing NLU benchmarks for such tasks are generally heavily curated. Though, of course, any model with non-zero test error could be presented with a potentially unreasonable benchmark entirely consisting of its own test errors. So this is so talking about, hey, if a benchmark is good, then a system that does well on a benchmark should also do well on samples of other tasks, as long as the specific sample of the task isn't it doing a bad, like the specific things it did a bad job on. So the adversarial examples that they talked about earlier. Expert authored examples. Expert constructed data sets for language understanding like Fracas, Cooper et al., and the Winograd Schema Challenge, Levesque, maybe, et al., have been crucial. Yeah, no, this word is crucial for defining several new tasks and introducing them as objects of study. However, expert example construction isn't desirable for the creation of benchmark for the use cases we focus on here. Setting aside this is what I meant, that like when I was first getting into the field, it was all about these like expertly crafted, super well validated data sets, and then we moved towards these more naturalistic scraped data sets. They're not all scraped, that sort of a thing, or crowdsourced. Setting aside the logistical challenges of creating sufficiently large and diverse data sets by expert label alone, again, expensive, expert authorship generally gives members of the research community direct fine-grained control over the data on which their systems will be evaluated. This has literally never occurred to me before, but that is true. Intentionally or unintentionally, this can produce data that is oriented towards linguistic phenomena that are widely studied and widely known to be important to the task at hand. While this can be helpful when building diagnostic data sets that focus on specific types of model failure, It is counterproductive when our goal is to build a broad coverage benchmark dataset to set priorities and guide progress towards the solution of some task. So basically what they're saying is if you let a bunch of linguists put together a data set, they're going to include the things that linguists care about. And I mean, he's not specifically calling out linguists here, but like NLP practitioners in general. And linguists tend to care about weird things, right? Like linguists in particular tend to care about edge cases and, you know, rare phenomena, because those are the things that help build our understanding the most, right? So again, thinking back to sort of like experimental behavior stuff, it's the things that pull apart systems right at the top, the differences there that make them interesting, right? It's the edge cases, it's the things that they don't do well, it's the error analysis that help us really understand what's going on in the system. And that includes the system of human language. Danietz? Sorry if I'm saying that wrong. And Sugawara et al. Work around this issue by leaning on taxonomies of required phenomena from outside NLP. This is a direction worth pursuing, but it is not clear that appropriate taxonomies will be available for most NLU tasks of interest, or that these taxonomies will be broad and thorough enough to be straightforwardly implemented as datasets. Oh, from psychology. Okay. So they're drawing in, trying to find my place again. So they're drawing in pieces of information and taxonomies and ways of organizing information from other fields. All right. Crowdsourcing. Yeah, I think we're probably going to be able to finish the crowdsourcing section, and then we'll pick back up with the adversarial section next week. Most recent benchmarks for language understanding have been collected, at least in part, through crowdsourcing example construction, where non-expert annotators are given some freedom to construct examples based on a simple set of guidelines. This has obvious appeal. Using non-expert annotators significantly lowers costs. Like I mentioned, experts are expensive. And using simple guidelines significantly reduces the risk that the resulting data will be skewed artificially towards phenomena of interest to experts. However, straightforward standard practice, as was used to collect data sets like SNLI, natural language inference, I forget what the S stands for, and SQUAD, seem to be relatively poor at producing difficult data sets that test the intended phenomena. Existing data sets focus heavily on repetitive, easy cases and often fail to isolate key behaviors. So if you ask a non-expert to put together a data set, particularly like crowdsource workers, they get paid by the item and they got to eat. So they're not going to spend a lot of time like creating the perfect ambiguous sentence structure. They're just going to be like, here's an example, pop, 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 pop. I'm going to like do as many as I can very quickly. So you're not going to get like unusual linguistic structures. You're going to get like the most common, the easiest to produce sort of structures. And this sets aside, honestly, the questions of labor exploitation of crowdsourced workers. So I mentioned that it's like much cheaper. Yeah, so fun, it's not fun. Kind of upsetting story from when I was in graduate school. So when we were, I did some behavioral work as part of my dissertation. So when we were collecting data from human participants and we were doing it face-to-face, so they were coming into the lab, or even if they were doing it sort of online through the university stuff, there was, a certain rate. So I think it was like $10 to have somebody come in and do like a half-hour, 45-minute experiment. But if you were crowdsourcing it, there was actually an upper limit on how much you were allowed to pay your participants, because if you paid your participants more than like other crowdsourced experiments, it was seen as like coercion. So they would want to keep doing your experiment even if they were like suffering psychological harm, because they knew that they'd get paid more. So there was like a limit to how much you could pay your crowdsourced participants, like an upper limit. And that stinks. Especially like so many of the, the major breakthroughs in NLP and computer vision and machine learning in general have relied on these really, really large data sets that have been produced by crowdsourced workers that just do not get really paid that much. And there was it a New York Times article maybe a while ago about sort of the, like, how much it sucks to be a crowdsourced worker and how much their labor isn't valued and isn't compensated appropriately, and how much they are defrauded basically, of their labor and not paid for work that they've already done, and the wage theft that's involved there. Yeah, and it sucks. I don't know. I understand the promise of crowdsourcing, but until it respects like human dignity, I'm not gonna be a huge fan of it. Anyway, that's just my personal stance on it. I think people should be paid for their work. I think people should have enough money to live on, and that's where I stand on the issue. And I don't think that crowdsourcing is like a great step towards, you know, equality and justice. And again, personal stance, my personal beliefs. You may have different ones. All right, so I'm gonna wrap it up there, and we will talk about adversarial filtering next week, and we'll wrap up the paper next week. Yeah, should be a good time. I also have a couple of papers that I'm interested in looking into a little bit more from their citations, which I always appreciate. And that's sort of the way of reading research papers, is that you learn a lot more about things that you're interested in because the author is pulling together a bunch of relevant research. All right, thank you so much for joining this week. Really interesting paper, a lot to think about. And this is really specifically talking about benchmarks for you know, the research community. But I think it's also for practitioners, for us as you know, engineers, it's really interesting to think about as a way to evaluate machine learning systems more broadly, right? How do you know that the initial data that you've used to set up your system is going to, you know, extrapolate well to new situations? How well is the you know, the data set that you're training on actually representing the data that you're going to see in the world once the system is deployed? And how do we think about that, and how does that affect the way that we build and evaluate systems? Yeah. All right. So I'll see you next Thursday. We're going to continue working on the paper. Tomorrow, we're going to be doing live coding. So last session, we set up our Rasa X server on DigitalOcean. And this week we're going to be, we have an action server, so we're going to be adding it to our cluster as a new server, and we'll put it up on Docker Hub and do all the containerization stuff. And it's been a bit since I've done that, so it should be a good time refreshing my memory on how to do all that. And also, I hope it wasn't today. I think it's next week. The release office hours. I'm trying to remember specifically what it's called. It's something that we've done. April 29th. Yes, excellent. It is next week at an hour before this time, 8 p.m. We're going to have Beyond the Release Notes. So this is I think it's going to be bi-weekly going forward. Webinar, I guess you would call it. Basically, a bunch of people who are responsible for different features in the latest version of Rasa are going to talk about them, and there's going to be a Q&A session, and that will be uploaded on YouTube after the fact. But if you want to participate in the Q&A session, go sign up. So that's going to be linked under the community tab on our YouTube. And that'll be April 29th at 8 a.m. Pacific time or 5 p.m. Central European time. And then the other thing to keep an eye out for is L3AI. So we had it last year. It's going to be online. So anywhere in the world, you are more than welcome to join in, learn about conversational AI, think about the direction the field's going in, learn some, cool tips and tricks, level up your skills. Yeah, so that is also coming up. And you can, I don't have the link to hand, but you can search L3AI, and the website is now up to date. So you can already get your tickets. All right. Thanks so much for joining today, everybody. I'll see you tomorrow for live coding, and have a great day.